Hi, I'm Adam Schaal, and I'm here today to talk to you about a deep dive in supply chain vulnerabilities and how Sec DevOps can save the day. A little more about me. I'm the Director of Enterprise Security at Contrast Security. Uh, Application security and product security is under my purview. So I spend a lot of time thinking about supply chain vulnerabilities and ways to mitigate them, especially in today's threat landscape. I've also spent about a decade making and breaking applications. So I have a good experience kind of on both sides of the coin with development and security. There's my Twitter handle and my website if you'd like to follow my work or get in touch afterwards. I'm also on the AppSec Village Discord under the same handle, Clever and Wise. Hit me up if you have questions about the content I'm producing or if you want to chat about my talk. I'll be available after the talk as well. Some of my hobbies include family time, home lab, home automation. I enjoy participating in CTFs and hackathons. I also enjoy working with the community. I helped start a local cybersecurity conference in Omaha, Nebraska called KernelCon. Love to have you out. Also, I help run a local DEF CON group. But let's talk about supply chain attacks. What are they? Besides being the 2021 buzzword bingo center square. Supply chain attacks are a cybersecurity attack vector where malicious actors basically target less secure elements in the supply chain. So if I read that, it's attacking the low-hanging fruit. Recently, there's been quite a few large supply chain attacks. Just today, JFrog analyzed PyPy software and found 8 packages that have been downloaded over 30,000 times that contained malicious elements. Also in 2021, Kaseya helped ransomware 1,500 businesses because of its own flaws in software and lack of patching. You may have also heard of the CodeCov breach, where an attacker exploited a flaw in the container build process and modified part of the bash uploader, leaking environmental variables, secrets, and more. And that affected 29,000 clients. And 2020's big one, SolarWinds. It led to a massive attack on American companies. And the attackers basically got into SolarWinds, changed some code maliciously, hid their tracks, and then the routine update that SolarWinds sent to all of its clients then added all the malicious code and backdoors to all of their clients. It was a huge attack in 2020. These are recent attacks, though. When I look at like the timeline of supply chain attacks, one of the first ones can be traced back to 1983, when Ken Thompson, the co-author of Unix, he created a C compiler that backdoored every program. So these have been, in the news, and InfoSec communities have been aware of it since 1983. So why are they still so prevalent today, right? Why is supply chain attacks, such a big deal now? Well, it's that weakest link part, right? When we look at the difficulty of an exploit, operating system attacks have always been more difficult to exploit than somewhere along the line in the supply chain. But it isn't until modern day times where supply chain attacks have actually started to really build out its impact level. Today's software, takes an enormous amount of dependencies. I think that something like 99% of software has dependencies of some sort. And now supply chain attacks have the ability to have a large impact on communities. So yeah, that large impact. There's dependencies in the code, NPM, Yarn, Maven, PyPy, NuGet, all kinds of things. And there's microservices in the architecture. And then there's vendors in the environment, and then hardware and everything. And you didn't write any of this. That Trusting Trust paper that Ken Thompson wrote. In there, he says you can't trust anything unless you write it yourself. But in modern software, the amount of stuff that you write yourself is so little compared to what you're pulling from other people that it's pretty much impossible. You didn't write your vendors. You didn't write the hardware. You didn't write all your dependencies. But talking about this, it makes you sound like, oh my gosh, you can't find Pepe Silva, right? Well, the scope is just way too big to discuss all of this. So we need to narrow our scope a little bit. We need to bring it down. So today's talk, we're going to focus on JavaScript attacks. Many projects use JavaScript and build dependencies. There's a wide range of experience and use. So I hope that a lot of people viewing this talk can relate. Also, most of the defensive strategies that we discuss can be used in other supply chain mitigations. So I'm hoping that this is ubiquitous enough that people can take pieces of this and apply it to other different software or supply chain levels. And then lastly, one of the reasons why I want to focus on JS attacks was in May of this year, the Node.js vulnerability reporting program shut down. And they closed all of their existing reports with an ask that researchers reopen their findings through a private company. And nothing against the private company, but a lot of researchers aren't going to double dip the work, or they've moved on. And so I worry that there's hanging node vulnerabilities that just never got triaged or any attention because they were in the backlog of the Node.js vulnerability reporting program, and now they're closed. So let's talk about the problem with the JavaScript supply chain, though. This is the fact. Modern software contains only about 22% custom code. And that's modern JavaScript applications. So 78% of it comes from open source dependencies or language libraries, which is an incredible amount when you think about it. Over almost 80% of your code you didn't write. And there's a problem with that. It's almost impossible to audit all of the code and dependencies. Managing vulnerabilities in dependencies is cumbersome and nearly impossible, right? And updating dependencies means continuously bringing in new code that hasn't been evaluated yet. So when you have code that goes in a dependency that asks for an update, you have to bring in code that you haven't actually looked at. And so it's risky to just update even. In other words, when you look at a dependency here, this is an engine IO dependency. This brings in 18 other dependencies. So it's basically the human pyramid, right? It's as secure or as safe as its weakest link. I mean, look at that guy in the blue hoodie. He's definitely falling, and that pyramid's gonna collapse. So let's examine some case studies and learn from mistakes that can help us inform solutions. These are some of the most famous cases, supply chain attacks in JavaScript applications. Well, not this one. This is popular. It's a Typosquatting vulnerability. I made this for a CTF 2 years ago. I cloned a React.js color picker, and then I added some code around it, warning people about typosquatting vulnerabilities. And I even have a flag. I discuss different types of supply chain vulnerabilities, and yet it still gets 8 weekly downloads. To this day, people are still downloading this because they spelled color with the British way, and they forgot an E on the word picker, and people still end up downloading this color picker. And even though in the README, I talk about typosquatting and I say, this is not the package you think it is. And people are still downloading it, which just blows my mind. That's basically what typosquatting is somebody goes and they downloads a package that they didn't intend to. Let's talk about a malicious update. This is a very famous vulnerability that I thought was insane with the amount of thought that went into it by the attacker. Event stream was a very popular NPM package, which exposed a lot of node helpers for working within streams. It had 1.9 million weekly downloads. There's two characters in this story. There's Dominic and Right9 Control, or the bad actor. Dominic is a 10x engineer. He's built out 600 or something NPM repos and packages, and he has a crazy level of community help that he's built out. So Dominic created Event Stream in 2011, and it had been kind of in maintenance mode for 2 years before September 18th. Right9 Control made a few commits on GitHub, basically adding unnecessary stuff to the repo. He then emailed Dominic and said, can I have permission to publish from this repo to NPM? Dominic went ahead and granted permission. Then in the middle of September 2018, he made a few more commits. He actually deleted some of his previous commits. It was, if you were actually watching these commits, it was kind of obvious that he was just doing whatever he wanted, and it didn't make any real impact on the code. And then he emailed Dominic and he asked for ownership of the GitHub repo and the NPM package. Now, Dominic wrote this in 2011. This is 7 years later, and Dominic had already moved off of it. It had been 2 years where he hadn't made a commit. But this package was still getting 1.9 million weekly downloads. So Dominic went ahead and transferred the ownership. He doesn't get anything from it. He hasn't used it for years. So he went ahead and transferred the ability to publish to the NPM repo to the bad actor. He also attempted to move the entire GitHub repo to the attacker. This is where the attacker really big brained it. He actually forked Dominic's repo, so Dominic couldn't transfer the GitHub repository to Right9 Control because he had a repo with the same name. So he couldn't transfer it over to him. And so Dominic still maintained the repo under his user. Right9 Control had ownership of the repo, as did Dominic. But if people went and looked at it, it still looks like it's under the same trusty person who's always maintained it, because Right9 Control basically blocked the transfer intentionally. Then September 9th, Right9 Control, this is where he kind of went nuts. He adds the dependency flat map stream into the GitHub repository, and he published it to the NPM package. So flat map stream was a dependency of event stream, and event stream was a dependency of a lot of major software at the time. So that's why it had such high volume. So now when you look at this dependency map, flat map stream is now one of the dependencies of event stream, and flat map stream turns out actually had malicious code in it. And this code would look for certain crypto wallets on your file system. And if you had said crypto wallets, then it would try to break them and send your cryptocurrency and your keys back to an attacker, back to a server which the attacker controlled. So right now he adds this vulnerability, and he adds the malicious code, and he publishes it. Then a week later, he actually removes the dependency and implements it manually, which you think, okay, well, maybe he figured out it was malicious. Here's where the difference matters. He publishes it to NPM as a major version number. So by updating the major version, right, he effectively locks anybody who uses a caret or a tilde to describe their version number in their package.json into the vulnerable version. But if they went and evaluated the current version, it would look legit. It would look like it was good code without any malicious code, because he implemented flat map stream manually and removed the dependency which had the malicious stuff in it. So all the people who download the latest version were fine, but all the people who had been using it for quite some time are basically locked into a vulnerable version. So it's another way that he's obfuscating this ability to detect this vulnerability. So yeah, like I said, if you go check out the latest code on NPM, the crypto mining code isn't there. If you check out the latest code on GitHub, the crypto mining code isn't there. Also, GitHub still points to your reliable Dominic, who you know. Right there is where he talks about how he tried to transfer it, but GitHub erred because he already had a fork on it. So Dominic had tried already to send this to another person. So his tracks were covered. He was mining wallets for 2 months before any discovery on any application that used event stream. The discovery is kind of interesting. It was discovered because the attacker used a deprecated library, which is hilarious to me, because he's basically attacking the supply chain, and he was using a deprecated library, which popped a warning, and some dev saw the deprecation warning and tracked it down and thought, what is producing this warning? And he figured out that it was this flat map stream. And then he thought, what's flat map stream doing? And that's where he noticed that some strange activity that turned out was the crypto mining. And the discovery took a huge effort. You had to get GitHub to remove the commit. You had to have NPM remove the package in each organization to ban the user. And then NPM even archived event stream and prevented any future updates from it. They rolled it back before flat map stream, and they prevented any future updates from ever being committed to it. So this brought a lot of attention to process, right? A lot of people didn't know that what's published in NPM doesn't have to match GitHub, that in any way. So what's on NPM could be fake. What's on GitHub could be totally different. A lot of people, thought, well, how could you transfer the ownership to this person when I use this? And the honest answer was that Dominic hadn't used it for 2 years, and a interested party came and knocking and offered to do some free development work. So it's things like these that really, lay out kind of the difficulty around protecting against supply chain attacks. So then more recently, you might have seen this one. This is a really interesting attack vector. Alex Burson published an article about dependency confusion, where he and another researcher noticed that PayPal had non-public dependencies, most likely internal, called out in their package.json. So basically these dependencies in red right here, they were internal dependencies. But if the So the build server, when it was looking for these dependencies, it would go to the public npm, and if it failed, it would then look internally. So they set up their build server incorrectly. It was first looking publicly before internally. And when it failed, it would go to an internal dependency. But if it didn't fail, it would download from this public npm repo. So they went ahead and registered those names on the public npm repo, and they were now able to get into the build server itself. And with Node, Node scripts, you can actually use something called pre and post install. So you can actually run your own code on this build server just by them pointing at one of your packages, which is crazy. And the amount of effort that it took is very minimal, right? It's registering something with that name. My coworker, Matt Austin, we read this article and we were talking about it, and he went and pulled Microsoft Teams and looked at their Electron apps dependencies, and he went and he registered some npm dependencies, and he was able to get hits from Microsoft's build servers, which is crazy to me that this is still super exposed and super vulnerable, and really a problem. So let's talk about some sec DevOps solutions here. How can we install guardrails to help us mitigate some of these vulnerabilities? First, sec DevOps. Let's acknowledge that we talked about the 2021 buzzword bingo square. Sec DevOps is probably the 2020 or 2019 buzzword bingo center square. What is it? Well, it's the process of integrating security into the development and deployment workflows. Basically, it's security processes and checks enter the lifecycle at a very early stage to keep up with the rapid DevOps release approach. One of the things that I always preach is that we want to be partners, not hindrances in AppSec. And so partnering up with DevOps and trying to engage in this rapid release approach really helps solidify that partnership between AppSec and development. So some of the things that your organization can do ahead of time, and really just as part of the process here, is squat your own enterprise. That sounds funny, but honestly, it's really easy to do, and it's probably going to save you on a lot of Typosquatting type vulnerabilities. One of the things you do is you purchase all potential typo domains for less than $10 a year. You can buy 20 or 30 domains, and don't forget combinations of alternate TLDs like .com, .net, .org. You want to grab all those. .gov is another popular one. These are things that you want to go and grab and own, right? And this isn't part of the supply chain, but you probably also want to set up email servers and have those email servers point to your internal security team. You don't want people accidentally sending out billing information to a wrong domain. You want to know about that and treat it as a teachable moment. Don't just register the domains though, redirect them. Point them to the main domain to help alleviate confusion. You don't have to pay to do that. That can be done without hosting. Again, this is a super cheap option, just a guardrail that you can put in place. And then register namespaces on public dependency managers. This is important because if you do that, you can help prevent some of that dependency confusion stuff that we talked about. If you register the names in similar spellings, remember Typosquatting, of internal libraries and packages on all public repositories, even the reserved name, even if they're never used. It basically prevents an attacker from tricking a developer into using an identically or similarly named package on a public repository. Speaking of, you want to activate namespaced modules. Many package managers, including Maven and NPM, support namespaced modules, which prevent the same name from being used by two different resources. Another good way to protect your enterprise. And then lastly, treat your list of internal packages as sensitive information. The success of these attacks depend on knowing the name of internal resources. And so organizations can't be cavalier about that. They need to protect it, and you can't just push all of your internal packages into a production client-owned, package that's easily decipherable. So this is the kind of stuff that you want to keep as private as possible. Some ways that you can guard against malicious updates: use a lock file. Lock files ensure that you get the same package version on every install. So if you're secure today, you'll be secure tomorrow. This would have really helped with the event stream vulnerability I talked about. Again, it was created in 2011, and in 2015, it really entered maintenance mode. And if you had been locked into that maintenance mode version, when FlatMap Stream was added at 3.3.6, version 3.3.6, you would not have installed it, right? So you would have never had to even install it. So that would have really saved the day in that scenario. Something else that I ask is that developers think before they install dependencies, right? Many organizations have limited visibility into the sources of their software, which is a problem. When you're a big organization, or when you're an organization doing a lot of M&A, a lot of mergers and acquisitions, knowing kind of the source of your software is vital. You need to understand the dependencies and track them at a very granular level. And this can be difficult, but if you don't start now, then you could regret it. It could be, in 2 weeks or 2 years, but the best time to start thinking about this and about where your software comes from is now and not tomorrow. And you can put in organizational policies and checklists for your devs, just as a good way to help guard against some of the problems with supply chain attacks. Some of the checklists would be, do you need to install this dependency? Is the package well maintained? Do they have like actual issues that get closed? Do they have open security issues? Does the package match the package manager source, right? Like, are they publishing the same thing that shows on their public repository? Can you write it yourself? This is a big one. I'm not sure if many of you have heard of the term or the program LeftPad, but a developer, another huge community developer, had 140 packages on NPM, and NPM decided to give one of his packages names to a company that wasn't even going to use it because they were the company and it was a trademark thing. And he had created the package, I think, before the company was even named. And he was mad, and he actually removed all of his modules that he built. Well, one of them was called LeftPad, and all LeftPad did was 9 lines of code. I think it just added spaces to the left of something. It converted it from white space to spaces, or something like that. But it was 9 lines of code, and it probably didn't even need to be 9 lines. And but he had made it at some point, and somebody used it at some point, and it got some spread. And eventually, Babel, the main transpiler of JavaScript, of modern JavaScript applications, had left pad as a dependency. So by removing his repos, he effectively killed Babel. And every modern JavaScript application, I'm talking Ember, Angular, React, all of the common JavaScript applications at the time, they all like just broke. They could no longer take the framework and convert it to vanilla JavaScript for use. And it was huge. It affected all of the JavaScript world and community. And it was just because this developer got mad and he removed what essentially amounted to 9 lines of code that somebody, when working on Babel, could have just made natively, and it would have been never an issue. So I always tell people about this when I educate them with this checklist, because that's something that easily could have been written themselves. But by inheriting a dependency, you've inherited another risk, right? You've opened yourself up to more risk by having this dependency. And another option is, if you're a little unsure about this dependency, is you can evaluate it as is and then fork it or clone it, and then just point to that directory. So if you're not sure it's getting proper updates and you like it as is, you can host it yourself and just point to that instead of the public one. And now you have complete control over that code. That code is now your code that you're using, and you're not taking any updates. One of the reasons why this is a good solution if you're willing to also, check the updates that it does get. Because if there is a security update, you want to make sure that you add that to your side. And so there's guardrails that you can set up here where you're hosting it yourself, but you're evaluating every update and then pushing it to what you hosted yourself. That's another option. Another thing that you want to do, part of the CIA triad, is you want to protect the integrity of these dependencies. One option is you can use a sub-resource integrity with CDNs, basically directing the browser to only pull a specific resource if the hash of the file matches the cryptographic hash that you've specified. So what you're doing there is you're saying, I expect it to be this, and if it isn't, the browser's not, the project won't pull that resource in, right? Which is what you want. If this is different than what you said it was, you don't want to pull it in because it's been modified, and it's potentially been modified maliciously. Also, you want to continuously monitor your dependencies. You can use tools like npm audit, retire.js, dependency check, and dependabot. These are good ways to continuously monitor your dependencies, but there's a stipulation that goes along with this. Make sure you understand the results, right? There was a great article recently, I forget who it was, but where they talked about how the npm audit results are very misleading because several of the results involved dev dependencies, basically build dependencies that never made it to production. So when I'm deploying an app that uses JavaScript and I'm using some packages to build stuff, it doesn't matter if the package that's building something has a cross-site scripting vulnerability in it, because that's on my build server, and all I'm using it for is to generate another package and deploy it. And if it doesn't get deployed with it, it doesn't matter to me. So you need to understand these results and really read through them and understand exactly what they mean. But you can always train people to do that, or you can add some sort of rules or run books around how to determine whether or not a finding is a finding you need to be concerned about, or if it's a finding that you can kind of put on the back burner. So that's just the stipulation with that one. Always prefer signed packages from official sources, because it reduces the chance of having modified or malicious content. And then something else, protect your deployment accounts, right? Because when you're pushing stuff to NPM or whatever, you could be someone in a supply chain, right? Like think of SolarWinds. They were in the supply chain of all of the companies that got attacked by their update, really, that by the malicious code put into their update. And so protect anything that you're deploying as well. That means two-factor, rotating service keys. Also use like role-based authentication on who can push artifacts. Really narrow the scope of who has the ability to do that, and put that into a trusted group, and then make sure that there's a process in place for rotating service keys. And then if somebody leaves the organization, make sure that there's a way to rotate their keys, or delete them from the group properly, so that they still don't have the ability to push something out into a package manager, which would be a big problem. So those are some of the ways that this matter, that you can protect against it. But honestly, like we talked about how this has been around since 1983. Why is it still such a problem? And what can we do about that? Well, it's still pretty ongoing because of two big reasons, I think. There's a lack of awareness, right? Without AppSec educating the product and the engineering teams about the dangers of supply chain risks, it can be difficult to get the priority it needs, right? And so I think that one of the things that you can do as AppSec engineers, as internal AppSec teams, is really build out that education, make people understand, hey, this is super risky and it could have a large effect on us. And here's what we need to do to safeguard it. And if we don't do it, that could be a problem. And make them understand. I mean, without that education, some people are unaware that just pulling in gobs and gobs of dependencies isn't the best idea. A lot of people think, oh, I can code so much faster if I pull in these 30 dependencies, and I'm pulling in things that'll do arithmetic for me or generate HTML or something, silly. That's not a great thing, right? So there's a cost analysis that goes with that. I mean, what's the time it would take somebody to implement something themselves? But they probably can do it, and you need to start factoring in risk with your cost analysis. And that brings me to my next point. Developers have extremely tight deadlines, right? We live in this in this world where software nowadays has tight turnaround times. Tech debt is growing. Developers, are getting pressure from product and public stakeholders. You got your investors, and some public companies have shareholders, and they have to produce results. And it's just, there's a lot of pressure. And so as AppSec team members, right, we need to be good team members. And one of the ways to do that is to fight to get them the time to code securely. And AppSec and development should be like a cooperation, not a competition. So you need to be good partners, good partners in your company. And that's something that I think really is a key component with some of this supply chain risk, because if you're a good partner and you're helping them get the time they need to code something more securely, or code something themselves instead of bringing in a dependency, it's a win-win scenario, right? They don't want to produce bad code. Everyone wants to code securely, and you want the company and the product to be secure. So remember that. That's one of the big takeaways. You're a team, and here are the guardrails that you want to implement with your team. Here's some of my sources. And thank you all for your attention. Like I said, I'll be on Discord if you have any questions. Hit me up. You can also follow me on Twitter and give me a message there if you want to touch base. I really appreciate it. Thanks for the opportunity to AppSec Village. I know that going virtually with 2 weeks left or 3 weeks left is extremely difficult. So thank you all to the organizers as well. And I look forward to, getting back to normal and hopefully being back next year in person. Thank you.